So this is another test of my tube cell with the SCR board. So my circuit is as follow. Here is an isolating transformer. After I have my variac, it's up to 15 volt. Up to 2 amps. Here is a 9XA board frequency generator. Here is the SCR board. I have here a frequency meter, and is the voltmeter which probe the output of my variac. Here is my bifilar coil with a gap between the core and my tube cell. Here is another tube cell for another experiment. So the water is a little dirty, and so here we go. So you can see here that the ammeter is pulsing between 1 amp and 2 amp, and most more than 2 amps. So with the potentiometer I can adjust the frequency of the gate frequency, and if I go to a right frequency, average 25, for example, hertz, which is a divider of 100 hertz, the amperage is more stable. So slowly, here we go. 25, oh, little bit more, 25 hertz. We can see the needle go from left to the right slowly, because I'm a little bit more than 25 hertz. Okay, it's the more stable I can have. So now that the amperage is stable, I can increase slowly the voltage, but not much, I'm afraid. I have to adjust the frequency. Oh, I can't go beyond. Here we go. So now we have average 33 volt at the output of the variac. That's not so stable. It's too much. Yes, let's go. Average, oh, sorry, you can't see it, but here we go. More than 30 volt, and with my oscilloscope I have across the cell only 13 volt, but it's a pretty good amount of HHO. One thing is very interesting is that if I add a new cell in series, I can put much more voltage on each cell with the same amperage. will change my circuit to the second cell in series with the first one. Yes. Okay. Like this. So now so now the amperage has dropped down until more than 1 amps. We still are on average 25 Hertz, and as you can see the two cells are running. So now I will try to increase voltage until I can. So now I'm about between 45 and 33. Don't know why it's fluctuate voltage, but as you can see here, the needle is go from left to right slowly, so it seems that my frequency is a little bit too high. If I decrease a little bit frequency, yes, it's pretty stable. In fact, when we look at the oscilloscope, we can see that sometimes we have 2 peaks and sometimes we have 3. Yes, this is 3. And this variation, you can see this variation with the needle here. With 3 peak there is much more amperage, and one there is only 2 peaks, as now it's the minimum of the needle. So we have to adjust the frequency to have always the same number of peaks, but so it's not very important for now. What is important is the amount of voltage that I can input. Now it's still pulsing, and I have a very good amount of I don't know if you can see it, it's very dirty, but very lot of bubbles here too, but it's not the same cell, and it's not the same production. Oh, not easy to focus on that. Yes, we have that, and perhaps we can see. No, too difficult to see. But here you have an idea of the production, and we are about 28 volt across the cell. I will try to increase the voltage again. Okay, as I increase the voltage, the frequency change a little bit, so I have to stabilize it, and it's at the maximum, little bit under, and I can increase again. because it's more stable. For now it's still pulsing. Average 2 amps. Little more. A huge amount of HHO. I don't know why there is this dirty soup. And across the cell we are about 34 volt. Okay. I will increase the voltage until this stop to pulse. So, too much voltage across the cell. I have to change the scale. So, sometime we are pulsing about, for now it's 41 volt. Yes. And it's a very huge amount of HHO. I need a more bigger jar to see the flow. So 2 cells in series. It's more easy to manage, in fact. It's hot. Yes, now I can vary the voltage and oh, it's time to go, I'm afraid. So see you later.